In that previous segment, we talked at a fairly high level about objects, the types of objects, how those types define behaviors, and how we'd like to start thinking about bundling systems up around types, around classes, around objects. We're going to now dive into looking at the details of how we would do that and then use some examples. But let me remind you of what we're after here. Our goal is to bundle together objects that share some common attributes with procedures or functions that operate on those attributes. So the idea is to cluster together in a single package information, details of data that belongs to an object, as well as methods that will work on that object. That's an abstraction, and that abstraction is really valuable because it's going to let us isolate the internals of the object, how it's stored, how it's represented, from how we use it. We can just think of an object like a primitive and think about how do we want to use that. And we're going to see that we can then build up layers of abstraction where we inherit behaviors, as we suggested earlier, from associated classes of objects. An object might have a set of base behaviors, and then there may be specializations of that where we inherit the base behaviors but define new kinds of behaviors. But the big thing is we're going to create our own classes. We're going to define behaviors of objects, and we're going to build on top of Python's underlying classes of types, the types of int and float and list and dictionary, to create our own objects. So let's look at that. In Python, we want the ability to create a new kind of object with a particular type. And the class statement is used to do that. So we would type into a file, and then we would read that into a Python environment or an idle environment, the keyword class, followed by a name, the name of the type, followed by one or more other classes. And I'll come back to that in a second. In this case, what I'm doing is I'm trying to think about points in the plane. So if I've got an x-axis and a y-axis, I might have a point up here, and it's got an x value and a y value, and I want to think about how do I capture a coordinate point, and how might I then do things on coordinates, like stitch together line segments or do other kinds of basic planar geometry. So, coordinates, going to be the name of a class, and inside of here I'm going to give it some attributes. And just like with def, the indentation helps me tell what statements are part of that actual class definition. So that's my framework. I define a class with a name, some things it's going to inherit from, and then I give it some attributes. Now, a class can inherit attributes. And what does that mean? Here, coordinate says it's a new type of object, but it is going to inherit from the underlying object class. And that's the basic class that Python has. Coordinate is said to be a subclass. Object is said to be a superclass of coordinate. And the idea is that I'm going to define some attributes here for coordinate. But it will also inherit, if that attribute's not present in my own definition, from object. So I can inherit things from object, or I can decide to have my own variation in here of something that's inside object. So I can actually block or override an inherited attribution by giving my own definition inside of there. Let's look at how that might work. So I want to create coordinates. And of course I want to be able to give them some initial values. Now usually when we do create an instance of a type, it won't just be empty. We'll want to have some initial values. And so we need to give coordinate a method for that. The way to think about this is when I call coordinate, which I'm going to do in a couple of slides, it's going to create off in memory somewhere a piece of structure that says, here's the instance of that coordinate. And what I'd like to do is to then inside that instance put in some information about that instance, the bundling together of those pieces. And I do that by basically giving it this init method. Now the fact that I'm defining init here means that I'm going to use this init method for coordinate, and I'm overriding an init method that sits up here in the object class. That init method usually just creates an instance, a frame, and returns it. Notice what this method says though. First of all, notice it's got three arguments. It's got an x value and a y value. That makes sense. Those are the things I'm going to be stitching together. But it has another argument here called self. And I'm going to come back to that in a second because that's going to be important. But just to clarify this, what we now have is we're defining a method. And method is just another name for a procedural attribute. It's a procedure because I'm defining it, just like I would with any procedure. But it's an attribute because it's done inside of the coordinate class, so it belongs to coordinate. This is the init method that works on any coordinate instance. Okay, so what's that funny thing self doing there? Well, whenever we call a method on an object, Python is always going to pass into that procedure the object itself. Think of it this way. I'm going to call coordinate. It's going to create out in memory somewhere a frame. That's the instance. That's the new coordinate I've got. I now want to store some information away in that frame. I need to know how to get to it. And so self is always going to point to the instance. Ah, that's nice. Because now look what happens when I actually call init. I call coordinate, it creates a frame, and then it says run the init method on this. And init has as its first argument self, second argument is some number. Notice what the body of init does. It says, oh, there's that funky dot notation. And that says, get the value of self. Oh, cool. It's pointing to a frame. And the dot says, inside of that frame, create a binding for x. And that binding is going to have as its value whatever that value is, which might be some number. And it'll do the same thing for y. It's going to create a binding for y right here, which might be something like 4. So the convention is that this first argument is always going to be used to point to the instance. And by convention, we always use the name self. You could call it Foobar or Fred or Joe or whatever you like, but it's going to confuse other programmers. So we really encourage you to stick with the convention that the first argument of any procedural attribute, any method inside of a class, is always the argument self. And you can see how it's going to point to the right place to get out what I want on that. That just says the same thing. It says that dot operator is used to define access to an attribute of an object. So in this case, init is creating 2 new attributes for the coordinate object. Similarly, when I want to get out information from an object, a class, when I'm accessing any attribute of an instance, I'm going to start by looking within the class definition. And that says when I'm trying to do an initialization or an init on coordinate, I'm going to start by looking inside a coordinate for an init definition. Since there is one there, I'm going to use it. If I had not put an init in here, then coordinate, when I called it, would have looked for an init definition within its frame, and having not found one, would have gone to its superclass and looked there. That'll be true of methods. That'll also be true of values. If I want to get the value of x inside an instance, I'm going to start with that instance looking for a binding. But if I don't have a name x in that frame, I'm going to look outside of it to the broader class to see if I can find it. Okay, just to clarify some details here, in fact, when we talk about procedural attributes, we also have data attributes. And those are often called instance variables. They are the variables inside an instance. So there are 2 instance variables for any instance of a coordinate. Now, what happens if I use it? Well, let's look at this particular call here. The first part says C is going to be a name I'm giving in the global environment. It's going to be a name I'm going to have to use to something. And now I'm using the name of the class coordinate. That is telling me, or telling Python, create an instance. Coordinate literally does that. It creates a frame somewhere in memory. And that is passed back in as the first argument to init. Now wait a minute, you're saying, whoa, hold on. I only see 2 arguments here, 3 and 4. They presumably match to those. Where's the self? Well, I'll remind you, in fact, I'm going to bring it up in a second, that self points to the instance and Python automatically passes that into an argument to any method. So coordinate has created a frame. I now call init. Self is pointing to that frame. X is pointing to the value 3. Y is pointing to the value 4. And inside of that frame, I take what self points to, which is that frame, and bind X. I bind Y. And then finally, this whole thing is what's returned as the value for C. So now I've got C as an object type. And inside of there, I've got some values. In fact, if you look down here, if I were to call C.x, that says get the value of C, which is pointing to this frame, and then dot says inside that frame, look up the value of x, which is 3, print it out. And of course, the other piece here is I can call coordinate many times. I want to make many different instances of this object. And each time I do, I create a new frame. And that's captured. This is just reminding us that Python automatically provides the argument for self. But when I do that, here's the way to visualize this. In my big world, when I define the class coordinate, it creates an environment, a frame for coordinate, that has information about its attributes inside of it. And then, when I call an instance of coordinate, it creates it with its own set of bindings. If I call it again to create origin, it creates a new instance with its own set of bindings. And now you can see there's no confusion about what value of x I want. If I ask for C.x, I'll get that one. If I ask for origin.x, I'll get that one. And of course, I can populate this with as many other instances of points as I want. So there's the way in which we define a class. We define attributes, both methods and data values or instance variables inside of attributes. Now let's look in the next segment about how we might use these things.